The leave plan of room experts has uncovered that using our new 101 billion toy, it will probably be forever before we can make significant progress. Assuming all goes as per plan, the excursion to Proxima B is expected to require around 20 years. However, practically, it will probably be a couple of years before we might actually start to affirm whether there is any life on that planet. The continuous investigation into whether we are genuinely alone in the universe continues, fueled by revelations from the James Webb Space Telescope. This telescope has previously discovered some incredibly fascinating peculiarities far from Earth that could bring us closer to answering this question. Our journey for figuring out our place and importance in the universe has always been central to human life, producing innumerable media creations and hypotheses over time. Our interest in the universe, along with our feeling of dejection, has driven us to continually search for others. Even though we are tiny in the grand scale of things, we may move closer to the answers we seek. However, are they really the answers we want, or are they simply unsettling discoveries? Join us as we explore the latest findings in the field of systems and exoplanets, as we embark on a journey that might lead us to encounter something we are not prepared to comprehend. In 2021, specialists made a huge advancement, possibly one of the greatest revelations in history, with the launch of the James Webb Space Telescope. An intriguing speculative question was raised regarding the capabilities of our technology. The question was whether, in the future, our telescopes could detect artificial light on another planet, such as Proxima B, the nearest exoplanet to Earth. Proxima B, found 4.25 light-years away, was recognized as having a permanent day side and night side, similar to our Moon. A speculative, advanced civilization on Proxima B could harness energy from the day side and move it to the night side using photovoltaic cells, which convert sunlight into power. In a paper co-created by Manis Ving and other researchers, it was demonstrated that a broad array of solar panels on the day side could be connected to future telescopes. Since the James Webb Space Telescope, JWST, has been upgraded, it has enabled us to extend our search for artificial lights on exoplanets like Proxima B. The fact that the JWST was able to detect these lights in 2024, with its enhanced capabilities, marks a revolutionary moment. The JWST may have found the very lights we've been searching for, potentially propelling us into a new era of human exploration. We should dive into the world of planets and exoplanets to understand how this discovery became possible. Since the beginning of recorded history, humans have wondered about the immensity of the universe. Who are we? Where do we come from? And where are we headed? These questions are timeless, yet incredibly complex. As we continue to advance technologically, one wonders whether we are any closer to answering these questions. If you were to ask a scientist, they could claim that we are still at the very beginning of figuring out our place in the universe. However, ask an astronomer the same question, and they'll likely become eager, ready to share the latest discoveries about the universe through the use of their advanced instruments. These instruments, which are often overlooked by the general public, are actually a direct reflection of human advancement. We now have access to the universe, and it's time for us to move forward and harness the knowledge and technology that makes the universe accessible. One such advancement is the creation of the James Webb Space Telescope, JWST, which holds the key to answering some of the most fundamental questions humans have about our world. The James Webb Space Telescope represents humankind's efforts to explore space and seek answers to long-standing questions. Are we alone? What is our purpose? And where are we going? This powerful infrared telescope is currently working to address these questions. But if you're wondering about Proxima B, it is sometimes referred to as Proxima Centauri B or Alpha Centauri B. This exoplanet is a super-Earth and orbits an M-type star. You might be confused by the term super-Earth, but don't worry. This article will explain everything. Super-Earths are planets that are larger than Earth but smaller than gas giants like Neptune and Uranus. They can be composed of gas, rock, or a combination of both, and their sizes range from 2 times the mass of Earth to several times that of our planet. Proxima B is a super-Earth exoplanet, meaning it orbits outside our solar system. The first traces of exoplanets emerged in 1917, but it wasn't until 1992 that the first confirmed discovery left scientists astonished. Another exoplanet, initially found in 1988, was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems, with 896 of those systems hosting multiple planets. Many of these exoplanets orbit around M-type stars. To understand M-type stars, it's essential to know that they are the smallest type of stars in the main sequence, often referred to as red dwarfs. These stars are incredibly common in the Milky Way, but their faint light makes them difficult to observe. Despite their dimness, M-type stars make up around 70% of all the stars in the Milky Way galaxy, offering a large number of potential systems where life could exist. Proxima B, orbiting one of these M-type stars, represents a promising target in our search for extraterrestrial life, as it resides in the habitable zone, where conditions might allow for liquid water to exist, an essential ingredient for life as we know it. The ability to study exoplanets like Proxima B is a direct result of advancements in telescope technology, particularly the James Webb Space Telescope. As we continue to refine our instruments and explore new methods of observing distant worlds, we may one day find that these far-off exoplanets could harbor life, or perhaps reveal secrets that will reshape our understanding of the universe. With each new discovery, we come closer to answering some of the most profound questions about our existence. Are we alone in the universe? What is our place in the cosmos? These questions have driven humanity's curiosity for centuries, and as our technological capabilities grow, so does the possibility of finding answers. In the future, it's likely that our exploration of exoplanets and distant stars will continue to yield new revelations. Whether we discover signs of life, evidence of alien civilizations, or even more fundamental insights into the nature of the universe itself, the journey promises to be one of immense discovery. Our curiosity and determination to understand the cosmos will continue to push the boundaries of science and exploration, shaping the future of space exploration for generations to come. Makes it hard to distinguish M-type stars, which have temperatures around 3000 Kelvin, moderately cool compared to different stars. Proxima B's host star, Proxima Centauri, has a mass generally identical to 1.07 times that of Earth. Curiously, Proxima B just takes 11.2 days to complete one orbit around its star, which is much shorter than Earth's 365.25-day orbit. Proxima B's star is very faint, radiating just around 1.6% of the Sun's total luminosity. In the apparent light spectrum, its brightness is even lower, creating only 5 to 6% of the Sun's visible light output. More than 85% of the energy emitted by Proxima Centauri is in the form of infrared radiation. Proxima B orbits the star at a distance of about 0.045 to 0.056 astronomical units, much closer than Earth is to the Sun. Proxima B was first discovered in 2016, and you may wonder why this exoplanet, despite the presence of millions of other stars, planets, and galaxies, has earned so much attention. There are a couple of key reasons for this. First, Proxima B is the nearest known exoplanet to our Sun, located just 4.2 light-years away. While 4.2 light-years might seem like a large distance, it is relatively small in the context of the entire universe. Proxima B is part of the Alpha Centauri system, a triple-star system. Despite Proxima Centauri's faint glow, the Alpha Centauri system remains one of the brightest objects in the night sky, behind only Sirius and Canopus. Perhaps the most captivating part of Proxima B is that it may be habitable, as it lies within the habitable zone of its star. This zone is where liquid water could exist, raising the possibility of life. Therefore, space scientists have been eager to investigate the potential habitability of Proxima B and other exoplanets like it. This is where the James Webb Space Telescope, JWST, comes into play. The JWST has four main goals: to study the light from the first stars and galaxies formed after the Big Bang, to explore the formation of stars and planetary systems, to understand the evolution of stars and planets, and to investigate the origins of life. As the JWST continues to study exoplanets like Proxima B, we are getting closer to achieving these objectives, ranging from searching for exoplanets to exploring extraterrestrial life. This mission is not only about answering scientific questions, it's also a reflection of human curiosity. Since the dawn of time, humans have been driven to explore, to search, and to understand everything in our universe, both animate and inanimate. This insatiable curiosity led to the search for extraterrestrial intelligence, SETI, an effort to find signs of something beyond Earth. SETI is one of humankind's most ambitious undertakings, akin to a cosmic game of hide-and-seek with our planet, scanning the vast universe for any sign of intelligent life. The search for extraterrestrial life began in the 1960s when astronomer Frank Drake first detected radio transmissions from stars. Although this groundbreaking discovery did not result in any contact with extraterrestrials, it marked the beginning of an important effort to locate such signals. Despite the challenges, the search continues, and recent advancements in technology, such as the JWST, are bringing us closer to potential breakthroughs. As the James Webb Space Telescope continues to observe exoplanets like Proxima B, there is growing hope that we may find concrete evidence of extraterrestrial life. If such evidence is found, it could change everything we know about life, intelligence, and the nature of the universe itself. Even if no direct proof is found, the discovery of artificial signals or light from distant worlds would have significant implications, suggesting that intelligent life may be surprisingly common. While the excitement of these discoveries is undeniable, they also raise important questions about our response to such findings. How would we react if we confirmed the existence of extraterrestrial life? Would we approach this discovery with curiosity, respect, and scientific rigor, or would it provoke fear and uncertainty? Humankind's history of responding to major discoveries, especially those that challenge deeply held beliefs, has often been complex. This raises further ethical and moral considerations. If we were to encounter intelligent extraterrestrial life, what would our obligations be? What ethical framework should guide our interactions with other forms of life, whether they are microbial or advanced? These questions are complex, and as we continue to explore the universe, they will likely become central to our understanding of our place within it. As we continue to explore the universe, these questions will likely become central to our understanding of our place within it. The search for life beyond Earth, whether microbial or intelligent, will continue to push the boundaries of our scientific, philosophical, and ethical frameworks. As technology advances, the possibility of discovering life on distant exoplanets, such as Proxima B, remains a thrilling prospect that challenges our assumptions and expands our horizons. In addition to the scientific advancements, such discoveries would also have profound societal and cultural implications. How would humanity's collective worldview shift if we found conclusive evidence of life elsewhere? Would it unite us in our quest for knowledge and understanding, or would it divide us with new fears and uncertainties? How would religious, philosophical, and political systems respond to the revelation of extraterrestrial life? The discovery of life beyond Earth, especially intelligent life, would force us to confront our own identity and place in the cosmos. It would challenge us to redefine what it means to be human and to consider our relationship to other forms of life. These existential questions, though still theoretical, are increasingly relevant as our ability to explore and understand the universe continues to grow. In the coming decades, we may see significant strides in our quest for extraterrestrial life. With advanced telescopes like the JWST, missions to distant moons, and the search for biosignatures in the atmospheres of exoplanets, the possibilities seem endless. Whether we find microbial life in the clouds of Venus or detect signals from an advanced civilization, each discovery will bring us closer to answering one of humanity's oldest and most profound questions. Are we alone in the universe? Ultimately, the search for extraterrestrial life is not just about finding another form of life. It is about expanding our understanding of life itself. It is about looking beyond our own planet to see what is possible in the vast, mysterious universe. Whether we find evidence of life or not, the journey will undoubtedly deepen our knowledge, inspire future generations, and ignite a new era of exploration and discovery. The answers may be far off, but the pursuit is what drives us forward. Always seeking, always questioning, always exploring.